till now we have learnt some aspects of different types of functions like polynomial functions, rational functions, and trigonometric functions. In this exercise, we shall learn about a new type of function called exponential functions and logarithmic functions. Okay, my dear children, in this exercise 5.3, we are going to discuss these 5 points. These are the concepts. These are the points we are going to learn. We are going to study these points. What are these 5 points? Exponential function. What is the definition of an exponential function? And second point, silent features of exponential functions. What are the features of an exponential function? Third one, logarithmic function. Here we define the logarithmic function. Fourth one, silent features of logarithmic function. And finally, properties of logarithmic functions. Okay, my dear children, are you ready to get the knowledge of these points? Well, right. Now come to the first point, that is exponential function. Exponential function, we are defining here exponential function. Okay, my dear children, the exponential function with positive base b greater than 1 is the function y is equal to f of x, that is equal to b power x. This function is called exponential function. Here base, this should be always greater than 1. For example, first example, y is equal to 2 power x. This is an example for an exponential function. Example 2, y is equal to 5 power x. This is also an example for an exponential function. Third example, y is equal to 3.2 power x. This is also another example for an exponential function. Similarly here, fourth example, y is equal to a power x, where a greater than 1, it is also an example for an exponential function. Y is equal to 10 power x. This is also an example for an exponential function. And y is equal to e power x. This is also an example for an exponential function. Especially in these examples, this fifth example, y is equal to 10 power x, is called common exponential function because here base is 10. If the base is 10, then the exponential function is called common exponential function. Remember this point, my dear children. Similarly here, last sixth example, y is equal to e power x. Y is equal to e power x. Here e value lies between 2 and 3. 2 less than e less than 3 is called natural exponential function. You know, in algebra, pi value is equal to 22 by 7. To denote 22 by 7, we are using a notation, a symbol pi. Similarly here, the value lies between 2 and 3 is denoted by this letter e. This function is called natural exponential function. E means e only. They don't give another letter. Any other letter they don't give. Understood this point, my dear children? Especially e value is the series. This series is called e value. E is equal to 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial and so on. The value of this series is equal to e. So if you find the value of this series, it lies between 2 and 3. Understood this point, my dear children? Right. This is the graph of 10 power x and a power x. This is a visual representation of the function, exponential function 10 power x and a power x. Y is equal to 10 power x, y is equal to e power x. Y is equal to a power x, a greater than 1. If you observe these two curves, the two curves are passing through the point 0 comma 1, and it is also an increasing function from left to right. If you observe the graph from left to right, it is moving towards up, so we can say that here this graph is an increasing function. Okay, my dear children, right. Now we are going to discuss the second point, that is silent features of the exponential functions. This is the second point. Following are some of the silent features of exponential functions. These are some silent features of exponential functions. First point, domain of the exponential function is R, the set of real numbers. For an exponential function, domain is set of real numbers. Remember this point, my dear children. And second point, second silent feature, range of the exponential function is the set of all positive real numbers. Now come to the range of an exponential function. The range of an exponential function is the set of all positive real numbers. Okay, my dear children, right. This is another silent feature of exponential functions. The point ordered pair 0 comma 1 is always on the graph of the exponential function. If you draw the graph, we have seen the graph of the exponential function y is equal to 10 power x, y is equal to a power x. If you observe the graphs, the two graphs are passing through the point 0 comma 1. It is one of the silent features of the exponential function. Okay, my dear children, right. Now come to the next silent feature of exponential function. Exponential function is ever increasing, that is, as we move from left to right, the graph rises above. If you observe the graphs of the exponential functions, y is equal to 10 power x, y is equal to a power x, the graphs are increasing function. If we are moving along the curve from left to right, the graph rises above. Okay, my dear children, right. Now come to the last silent features of exponential function. For very large negative values of x, if you take negative values for x, the exponential function is very close to 0. The graph very close to 0. In other words, in the second quadrant, the graph approaches to x-axis. The graph approaches x-axis but never meets it. It never meets x-axis, but it is very close to x-axis. Okay, my dear children, these are all silent features of exponential functions. Understood, my dear children? Right. Now come to the third point of discussion, that is third point, logarithmic function. Now we define logarithmic function. Okay, my dear children, please pay attention, my dear children. Let b greater than 1 be a real number. Here b is a real number and it is a greater than 1. Then we say logarithm of a to base b, logarithm of a to base b is x if b power x is equal to a. See here, b power x is equal to a by implies log a base b is equal to x. log a base b is equal to x. So this is called exponential function. We converted this exponential function as logarithmic function. Okay, my dear children, in this function, this is read as log a base b. This is a number here, base. It is also a number, but especially here downside number is said to be base of this logarithmic function. Okay, my dear children. Now come to the domain and range of a logarithmic function. Log a base b. For this function, domain is positive real numbers or plus positive real numbers, and range is set of all real numbers. Range set of all real numbers. Okay, my dear children. Right. Now let us take some examples to understand this definition. See, first example, y is equal to log 5 base 2. This is one example for a logarithmic function. Second example, y is equal to log 10 base 2.3. It is also an example for a logarithmic function. Third example, y is equal to log 2 base 10. This is another example for a logarithmic function. Similarly, y is equal to log 10 base c. Log 10 base c. In general, we denote it as ln10. Here we are not writing any base. If any base is not given, we consider its base is e. Remember this point, my dear children. Okay. If the base b is equal to 10, if base b is equal to 10, see this example, third example, we say it common logarithms. So this is called a common logarithmic function. Whereas if the base b is e, see the fourth example, example number 4, then we say it natural logarithms. In this case, we say that this is a natural logarithmic function. I hope you understood this point, my dear children, well. Right. Often means in general, natural logarithm is denoted by ln, italic letters ln. So this denotes natural logarithm. In this chapter, log x denotes the logarithm function to base e. Here base is not written. Observe this logarithm function, my dear children. Here base is not written clearly. So we have to assume that here base is e only. Okay, my dear children. Remember this point, my dear children. That is lnx, italic letters ln x will be written as simply log x. Understood this point, my dear children? Therefore, ln x equal to log x only. Log x, what is the base here for this logarithmic function? E. Here, no base is given. It means the base of this logarithmic function is e only. Remember this point, my dear children? Right. Now, come to the visual representation of a logarithmic function. Graph of logarithmic functions. See here, y is equal to log x base 2. This graph is passing through point 1, 0. Y is equal to log x base 3. This graph is also passing through the point 1, 0. Y is equal to log x base 10. This graph is also passing through the point 1, 0. Observe all these graphs, my dear children. Okay, right. So now come to the next point of discussion, that is the fourth point. Some silent features of logarithm function to any base b greater than 1. Now we are going to discuss the silent features of logarithm function to any base b greater than 1. So first one, we cannot make a meaningful definition of logarithm function of non-positive numbers. We can't define logarithm of non-positive numbers, and hence the domain of log function is r plus. R plus means only positive real numbers. Logarithm function is defined only for positive real numbers. For non-positive real numbers, we can't define logarithm function. Understood this point, my dear children? Right. Now, second point. The range of log function is the set of all real numbers. Previously, we explained, we discussed this point. The range of logarithmic function is set of all real numbers. Okay, my dear children? Right. Now come to the point number 3, silent feature. The point 0, 1 is always on the graph of log function. If you observe the graph of logarithm function, the point 0, 1, all logarithmic functions are passing through the point 0, 1. Understood this point, my dear children? If please observe the graph of logarithmic functions. Previously we have drawn some logarithmic functions graphs. Okay, my dear children? Right. Now come to the fourth silent feature of logarithm function. The log function is ever increasing. That is, as we move from left to right, the graph rises above. If you observe the graph of logarithm function, it is increasing function. It is an increasing function. If we move along the curve from left to right, the graph rises above. Understood this point, my dear children? Right. Now, fifth silent feature. For x, very near to 0, very near to 0, the value of log x can be made lesser than any given real number. If we are taking the values for x very close to 0, then the value of log x can be made lesser than any given real number. Very little small real number we get the log value. In other words, in the fourth quadrant, the graph approaches y-axis but never meets it. If you observe the graphs of the logarithm functions in the fourth quadrant, it approaches y-axis. It is very close to y-axis, but it never meets y-axis. Understood, my dear children? Right. Now come to the fifth silent feature of logarithm function. Please observe this graph, my dear children. Here y is equal to e power x graph. This graph is, or this curve is passing through the point 0, 1, and y is equal to log x base e. Y is equal to log x base e. This graph, this curve is passing through the point 1, 0. Here y is equal to x. The dotted line denotes the graph of y is equal to x. So the adjacent figure gives the graphs of y is equal to e power x and y is equal to log x base e. It is to be noted that the two graphs are the two curves are the mirror images of each other reflected in the line y is equal to x. Suppose if you observe if you imagine this is a mirror, then The mirror image of this graph is this one. The mirror image of this curve is this one. Understood this point, my dear children? Therefore, the exponential function and the logarithm function are said to be inverse function to each other. Logarithm function is inverse function of exponential function, and exponential function is inverse function of logarithm function. Okay, my dear children? Understood? Right. Now come to the last point of discussion today. That is the fifth one, properties of logarithm functions. These five are properties of logarithm functions. These are very important for the next exercise as well as for the upcoming chapters. Remember these points, my dear children, well. First point, log A base log P base A, log P base A is equal to log P base B by log A base B. See here, this is written as a numerator and this is written as a denominator. Base is changed, base is B here, whereas here base is A. This logarithm function can be written as like this. Okay, my dear children? Right. Second property, log PQ base A. Log PQ base A is equal to log P base A plus log Q base A. We use this property very frequently, my dear children. Remember this property. Log PQ base A is equal to log P base A plus log Q base A. Okay, my dear children? Right. Next, third property, log P power n base A. Log P power n base A is equal to n into log P base A. We write this power as a numerical coefficient here. N into log P base A. I repeat this property. Remember all these five properties well, my dear children. Log P power n base A is equal to n log P base A. Okay, my dear children. Now fourth property, log P by Q base A. Log P by Q base A is equal to log P base A minus log Q base A. I repeat this property, my dear children. Log P by Q base A is equal to log P base A minus log Q base A. Here PQ means plus, P by Q minus, P by Q means minus here. Okay, my dear children, remember these properties well, my dear children. And last property, log A base A. If number and base are equal, then its logarithm function value is 1. Understood these points, my dear children? Remember these five properties of logarithm functions. Okay, my dear children? Right.